Hi, my name is Bernard Yan Jr., and my project is Telemachus, which is a tutoring system for novice programmers that estimates how much a student is relying on outside help by watching the coding process and then uses that time to decide what to ask the student next. This name is deliberate because Telemachus is the student in the Odyssey and the one being guided, not the tutor. Everything I'm about to claim about the problem comes from these 9 sources, so I want them on the screen up front rather than buried at the end. So the links are on the side, and I'll name each one as it comes up. So, the problem: AI solves the assignment, it does not solve the course. Prater ran 21 novice programmers through a task with generative AI. All but one solved it, but the students who were already prepared recognized the flawed suggestions and moved faster, while the underprepared students missed the flaws and accepted them and still shipped the working code. The thing is, the grade doesn't distinguish those two students that the gap this project is about. The harm is unevenly distributed and invisible to the assessment. Design detection has has been tried and it doesn't hold up. Pan found 5 detectors perform at a chance on AI generated code. Dick found GBT 0 falsely flagging human essays. Kundu got 85% with keystroke dynamics, but collapsed to the low 60s on students the model hadn't seen. Zen is the pivot point. Text alone wasn't enough, but behavior helped. So the processes hold signal, the artifact doesn't. And this is what Telemachus uses. Importantly, I'm not using it to accuse anyone. So the 3 commitments hold the design together. First, the student never sees the estimate, so there is nothing to gain. Second, the estimate never touches a grade. A wrong verdict costs 1 extra question. Third, every tutor responses goes through a verification gate before it reaches the student, because Hellas showed that models hand out solutions even when the prompt forbids it. The prompt isn't the safeguard, which, if you watch my second milestone video, that's something that actually happened and we fixed it. Well, I fixed it. Architecturally, um, a React for the architecture, a React I use a React front end with a CodeMirror 6 editor, which streams editor metadata over a WebSocket to a fast API backend. The backend sees that a paste occurred in position and size. It really never checks its contents. So student code only leaves the browser on a run or submit, and then it goes to a disposable sandbox with resource caps, not to the language model. Students work through 3 difficulty levels of 9 tasks with a consecutive failure counter that resets on each pass. Alright, so 17 features in 5 families, which are pace, edit, timing, execution, and burst. None of them read the code. They're actually computed over a rolling 30-second window, refresh every 5 seconds, and shorter and you average activity away. Longer and you lose the distinct episodes. A single pace or a single pause means nothing on its own. The signal is the shape of the activity over time. And I have a little video right here. I don't know, I can move myself out the way, but I think you can show it. As you can see, just type in everything. And on the side, you see everything that is Going right here to the pace, to the timing and the edits, and the timing execution. Also, you see how the tutor says, "Hey, heads up! I noticed you pasted something. Something's up." All right, we're done. All right. So here's what the verdict actually. Here's the verdict. An assessment fires at most once a minute or once every 10 seconds after a pace, and only if at least 5 events landed in the last 30 seconds. Three consecutive failures always wins. That student gets the most concrete hint. Reliance. High reliance with confidence at or above 0.70 get a comprehension probe. Everything else gets a guiding question. Then the gate, no calling the requested function, no define and call, no acquisition language, fail, regenerate once, and if it still fails, there's a fallback to fix the question. And this is a loop end to end. A student, well, yeah, a student on the temperature conversation task asks for help with no history to condition on. The the tutor asks about the inputs and outputs. The submission fails a test case. Then the student pastes over 200 characters. The the assessment cadence tightens, and the student gets advice about working with unfamiliar code. Again, this shows that it's not an accusation. The next verdict comes back high with a confidence above 0.70. So the tutor asks them to explain what the pasted code does. Later on the file, you'll see the writing task, the output, and the flag flips, and the tutor asks about the file instead of the return value. Let's see, just trying the code. Yeah, and then and that's how the system works in use. that. Okay. Let me make sure I got it. Okay. All right. So there's no reliance annotated corpus of Python sessions. So I wrote two generators. One emulates a genuine authoring, so character by character with log normal pauses, periodic runs, errors on about half of them, deliberate pauses, and small detect deletion rate. The other emulates offload, a long pause, a 600 character, a few characters typed on top, and a run about 30% of the time. 5 seeds each and 10 traces all through the production pipeline. And also for clean separation, 5 out of 5 low, 5 out of 5 high, no moderate verdicts. I want this to be honest about what that shows. The pipeline works end to end, and it says nothing yet about the real students. So for the second experiment, does the reliance signal actually change to their behavior? I scripted one struggling student dialogue and ran it twice. With the signal visible, the tutor asked a question every turn without it, and questions were mixed with direct guidance. So the signal reaches the output, but the dialogue was scripted. So I can't tell how big that effect is with real students. And the verification gate hasn't rejected anything in production, which means nobody has used it yet. So being straight about the limits, I have used 10 constructed traces, 3 lessons, and 9 tasks. Leak checks only catch code, so a solution written out of pros gets through. The 0.70 confidence threshold was chosen, not validated. A language model is making the reliance call rather than a trained classifier. And the ethics work isn't done. It has no consistent flow, no retention policy. And while student code never reaches the model, every chat message goes to a third party. Those three have to be solved before this goes into near a real classroom. So what's my next steps? The big one is replacing constructed traces with real students sessions, and based on Condu, I expect performance to drop substantially on unseen students. So I'd rather find that out early. Also, I will extend the leaks to check the pros and add knowledge tracing, broaden the task bank. But the one that matters most is a control condition. Busina found that a cognitive forcing helped students with high need for cognition, and did nothing for those with low need for cognition, which is exactly the population this system is built for. If Telemachus only helps the students who were already, deliberative, it widens the same gap it was built to close. So to close out, the system doesn't decide who cheated. It decides what to ask next. It reads the process rather than the product. It never shows or grades the estimate. And a wrong verdict costs a student one extra question. What I have is a working pipeline, validated on a constructed trace. What I don't yet have is evidence about students, and that's the next thing to get. Thank you, and if you have any questions, I'm welcome to answer.